Hello and welcome. Really glad you're all here. Today, of course, we're joined by Rich Heimann. He is the author of Sutskever's List, which is, of course, an exploration of one of the most talked about and somewhat mysterious reading lists in modern AI. For those that don't know, of course, this is a set of papers that the Open AI co-founder and chief scientist Ilya reportedly recommended to understand the foundations of modern AI. I think Rich has done something incredibly valuable with this book. He's unpacked those papers for us. So this event today, it won't be a traditional presentation. It's more as a guided conversation about ideas. And we'll talk about the origins of this list and really what these papers reveal about intelligence and about AI in general. And of course, what might be missing and where all of this is heading next. So Rich, with that, thank you so much for joining us today.
Thanks for having me.
Let's jump in and kind of start with the origin story. One of the questions we got was just regarding the list itself and when it was first shared. Is Ilya known to have shared his actual list with anyone besides John Carmack?
Yeah, great question. The toughest probably question I'm going to get today. Yeah, so the list is real. I mean, at least according to John Carmack, he's talked about the list publicly. He has urged Ilya to share the list. And the book, of course, is sort of interpretation of the list. That's a firsthand account, which is John Carmack's account. And the list, however, hasn't officially been published again, despite John Carmack's public encouragement for Ilya to share it. And so there's no like publicly verifiable trail of the list. And according to Carmack, I guess the list was deleted according to Meta's email policy. There have, however, been a number of sort of like recreations, likely versions of the list that have circulated online. There's almost sort of this, I think, mythos around the list itself, and maybe that's the fact that the actual list has never been shared has sort of allowed people to create these reconstructions and debate about what should and shouldn't be on the list. So I think it's unfortunate that the actual list has never been shared publicly. I do think that there have probably been private versions of the list maybe circulated at places like Meta and OpenAI, but no public version has ever been released. That being said, I think despite that, it's pretty interesting how the community has kind of like pulled together to try to like again like create these reconstructions.
Just kind of thinking about that. How much of this list is confirmed versus like reconstructed from these public clues or interviews or citations?
They're all reconstructions, so presumably reconstructed on something. I took the most popular reconstruction, and that's what the book is grounded in. I looked at every, interview, public appearance that Ilya has made over over the last 15 years, and really tried to like ground each paper in comments, public statements that Ilya has made, just to make it a little more realistic, I guess, in that regard. And what is interesting about the reconstructed list that the book ultimately adopts is that Ilya does talk about many of these papers. And what I also think is interesting about the list is it's not like the most cited papers over the last 15 years. I think you could create a reconstruction of the list and it could just be like sort of like a naive sort descending kind of list of citation counts or something to that. But it's not just that. I mean, it certainly has ResNet, which is the most cited paper of the 21st century. It's got the Attention is All You Need, which is a transformer paper, which is, I think, now number 7 on the all-time list, at least in the 21st century. And so you could certainly do that. And the list has some of those artifacts, but it also has some weird sort of niche topics like order matters and pointer networks and even Turing neural Turing machines. It's not just like the most obvious papers that you would naturally think of. AlexNet maybe being another one of those papers that you would naturally like sort of append to a list like this. It's got some weird things that Ilya has talked about in the past. And so it's, writing the book, it's been fun to speculate of like, okay, even if you don't accept that this reconstruction is the authoritative list, and there's no ground truth to make that determine one way or another, but it's still interesting to speculate about like how do these papers, which Ilya has mentioned, almost every one of them he has mentioned publicly, how would those shape his mental model? And I do a technical analysis of each of the papers, but it's also like, what does it say about the compiler? Like, what does it say about, Ilya? That's an interesting side story, I guess, of the book.
This, I think it all raises kind of a deeper question about time and context. So, do you think is this list best understood sort of as a fixed set of foundational papers, or would you say more of a dynamic, like intellectual roadmap, right? Something that continues to evolve over time?
The way I think about it is sort of AI canon. It is the canon of modern artificial intelligence, perhaps more specifically of deep learning. But I think that's part of the attraction too. I think there's something almost seductive about sort of the promise that Ilya gave to John Carmack when he shared the list, was that it explains 90% of what's going on in AI today. And so I think that suggests that it's more of a fixed representation, not necessarily a dynamic roadmap. It provides a nice foundation in a field that is churning out thousands of papers a year, that you could pick up, these 27 papers, and you would get some like substantive foundation of where modern deep learning is. At times I thought about it as kind of like an MVP, like a minimal viable, but instead of P, instead of product, it's more of like a minimally viable mental model for deep learning over the last 15 years or so.
I think that's a great way to think about it. Do you think newer research is being like implicitly added to Sutskever's list, even if no formal version exists?
I think so. What I think is really hard, though, if you're new to the field or you're in engineering with a lot of engineering experience, but you don't necessarily like get into the weeds of like the research, is that it's really hard to interpret new research in isolation. If you're trying to figure out like what matters in AI today, even moving forward, I think the most recent paper on Sutskever's list is from like 2021, 2022. Obviously, a lot of interesting things have happened over the last few years. How do you even make sense of that if you don't have the historical context? And I think the list provides that. It provides sort of a foundation to interpret what is now happening in the field. That being said, I have seen some interesting efforts on the part of other people to kind of like extend the list, which I think is sort of a fun intellectual exercise. Carmack has talked about, I think in interviews, he often quotes about 40, and whatever, about 40 could mean anything. It could be 30, right? Or it could be 27. The list that I use, the reconstruction, is 27 papers. But people have like looked at that gap between the public statements made by Carmack about 40 and looking at the most common reconstruction 27, and they've tried to speculate of like what those papers are. I like that idea of sort of the lost papers. It's sort of like an Indiana Jones mystique to it. Yeah, like the lost papers, the lost ark. But I think if you look at the list, and I don't know if there are any questions specifically about the composition of it, it is entirely deep learning, and that's interesting. Because it doesn't include reinforcement learning, which Ilya has spent, not his whole career, but portions of his career looking at reinforcement learning. It doesn't have meta learning. Like there are a lot of things that you might expect to find that are absent in the list of 27. And so I think in the lost papers, a lot of the reconstructions focus on the gaps. They focus on like, well, what are the important RL papers over the last 15 years? How does meta learning play? How do some of these other themes play in sort of a lost papers list?
And would you describe the list as like a historical snapshot of key breakthroughs up to a certain moment in time, or more as like a framework that still defines the frontier today?
Both, I guess. I do think it's a snapshot. It's a snapshot of like roughly AlexNet to maybe scaling laws, Kaplan scaling laws, 2020, 2021. The strategy I took with the book is I did extend that a little bit. So I do pull from research before and a little bit after, just to kind of add relevant context to the list. But again, my analysis is trying to stay kind of faithful to the list. I want things tethered directly to the list, and it's not meant to be sort of like a history of AI, much less like a history of deep learning, but again, sort of like this little snapshot. So I think it's definitely a snapshot, but I also think it's a framework because most of the significant breakthroughs during that period are built sort of on these common themes,
Yeah.
like these training tricks and architectural innovation, scale, of course, being a part of that. In that regard, it is sort of a framework for engineers specifically to understand like what moved the frontier over the last 15 years. And I think that might be indicative of what might move the frontier in the next 15 years.
Let's shift, I guess, from the mythology more to the lived experience of actually reading these papers. Anyone who's opened an AI research paper probably knows it's not exactly light reading. One of the questions we got was, which paper on this list do you personally struggle the most with when trying to kind of really understand it? And what helped it click finally?
They're not easy reading. And I think that's what makes a book like this interesting and maybe even valuable, hopefully valuable to readers, is it's trying to do some of that interpretation. And also it's important to understand any research aside from, the difficulty of the concepts or the mathematical terms. And as a side note, I've read papers recently that have just looked at the difficulties. I think we all intuitively understand that academic papers are difficult to read, but I think they've gotten harder to interpret over time. And there have been a couple of research papers that I've read over the last couple of years that have sort of talked about this trend. It's reflective of perhaps the goal of academic research kind of shifting more toward reproducibility. And so it becomes very technical and it becomes very explicit and jargon filled. It doesn't use metaphors and intuition. It doesn't provide historical exposition or anything like that. I think the problem is only getting worse. And I hope to see more books like this. I would love to see a Sutton's list and a Silver's list and a Schmidt-Huber's list. Part of the list, interestingly, to this point, is it includes things like Karpathy's work on the unreasonable effectiveness of RNNs, which was written in 2015. It includes Chris Ola's work about understanding LSTMs. It includes Stanford's course on computer vision and machine learning. Well, I think that was 231N. And it includes someone else. Sasha Rush's work on the annotated transformer. And all of those are examples. Those aren't academic research papers. They're blogs effectively. But they went viral. And I think they really explained the technology to a very excited audience that was trying to understand these concepts at a time when like people were just starting to adopt them. They all went viral. And I think it shows that academic papers are really important, but they're not the only sort of pedagogical tool that researchers and engineers will need to understand the field. So,
Mhm.
to answer your question, sorry for being so
No.
loquacious about it. It's like I wrote a book recently on this topic. What was the question again? Personally struggled with the most?
Yeah, like, was there one paper in particular that you really struggled with?
I think the Kaplan paper was tough just because a lot of the papers, like AlexNet, for example, it's like a traditional machine learning paper. It includes like, oh, we'll talk about the method, the architecture, how we trained it. It has some sort of experiment. The result of the experiment is the headline. And so the interpretation of those kind of like traditional machine learning papers, I think, are pretty easy. Kaplan's paper, which is scaling loss, that was difficult because it's just a bunch of loss curves and they all interact with one another. And it's not because the math is necessarily hard, but it's trying to interpret the interactions of a bunch of different loss curves. And it also like challenges, I think, your intuition about like what constitutes progress in the field.
Or was there a moment where it just clicked? I mean, was there something that made it click for you?
Yeah, I think it was interpreting them as sort of an economic argument of progress in the field and not like this because, not this mystical argument about like intelligence, quote unquote.
For engineers or technical readers who are new to all of this research, how would you say they should approach the book?
Read it. It's a good start. No, I would say probably read it front to back and just kind of like build up a general intuition on like what has happened over the last 15 years or so. Don't really get bogged down in any like one paper. And then maybe go back, and if there were like a couple of papers that were like really resonated with you, is to download the white paper itself, try to interpret the paper directly instead of through my words. Maybe trying to reproduce or implement like a lightweight version. I just saw somebody post over the holidays in December, posted a GitHub repository that was a NumPy implementation of each paper. And I think that's a great way also to build up additional intuition about each paper.
After studying all these papers together, are you seeing some sort of conceptual threads that connect them all?
Well, deep learning, definitely. Again, the list is just deep learning. Also, representational learning. The book starts with AlexNet and really kind of setting the stage of like the worlds AlexNet entered. And obviously, it was a challenge to, or at least it will, if you're unfamiliar with AlexNet, after reading the book, it'll be obvious that it entered a world where people weren't learning representations and allowing sort of like gradients to discover the structure. It was predicated on feature engineering. And so representational learning and allowing the models to learn structure, or what Elia calls the secrets in data, I think is a really important theme that I come back to several times throughout the book. A bunch of architectural tricks, basically like how do you stabilize optimization and smooth the loss surface so you can enable deeper models and then benefit from that scale. And there are a bunch of like regularization tricks, optimization choices, residual connections, obviously is perhaps the most important architectural trick in that regard.
Yeah. Is there what you would call a minimal theory of intelligence, like compression, prediction, world models, planning, that you think unifies this list?
I think so. Chapter 8 is all about compression and minimum description length and using bits to regularize networks. I don't think it's not a settled theory. It's more of a synthesis of like what's happening to these models in the background. It's obviously lagging behind the practice of deep learning, but this idea of compression and prediction is slowly catching up to the practice. But that being said, I don't view it maybe as a theory of intelligence. Acknowledging again that even if it was, it would be an unsettled theory at this point. It's more of a explanation of why they work as well as they do. I try to wrestle with this a little bit in chapter 9, where I try to like get people to move away from notions of intelligence, because there's some sort of like essence hunting that goes on there. It's like, well, we're searching for intelligence. And I think practically speaking, we're not really doing that. We're trying to build these models to perform well on public criteria, which are these benchmarks. And we're not really thinking seriously about whether that constitutes intelligence or whether that's real intelligence. Once you try to find this or explain this as a theory of intelligence, maybe machine intelligence is appropriate, but like when you start talking about it in terms of intelligence, you open up the door for criticism. And I think that's what you see a lot of skeptics sort of latch onto, is like, this isn't real intelligence, this isn't real understanding. They're basically like withholding acknowledgement of their effectiveness based on the lack of intelligence. And so my chapter 9, which focuses on Shane Legg's work, a paper or his dissertation from 2008, really tries to get people to walk back altogether on like this theory of intelligence. There's a lot of work going on explaining how these models work. Again, compression. The intelligence thing is sort of a trap.
Whenever you try to unify something that complex, I think tensions start to appear. We got this other question that asks, are there papers on the list that actually contradict each other philosophically or technically? Which I thought was a really interesting question.
That is a great question. Yeah, I think so. There are several papers that are about recurrence, and there are several papers about attention-based neural networks. And so what's interesting about those is that attention is all you need is the paper that introduced the transformer. What they meant by all you need is they meant you didn't need recurrence or convolutions. And many of the papers on the list include recurrence and convolution. Having all of these different like phase transitions in the field, I think is important from a historical context. And it shows how like one architecture replaced another. But, you could perhaps also look at that as maybe a contradiction, though I think my characterization would be sort of a tension that goes on in the field. rather than an explicit contradiction.
Yeah. Where does the field still lack a coherent theory? Is there a lack? Maybe there isn't.
I think the field probably lacks theory. It is an engineering field that is mostly preoccupied with what works, not necessarily why it works. And I think that's one of the reasons why the theory has lagged behind. You're gonna have to read the book. But chapter 8, I think, is probably the chapter that most seriously comes at this. It kind of tackles like, why do models generalize as well as they do? Why are they so robust? How is generalization different than memorization? I covered double descent, grokking.
So everyone read chapter 8. One of the most revealing, I think, exercises with any canon, as you think about it, is probably also asking what's missing. So maybe we can pull back and take a look at what some of those omissions might be. One question we had received was, what gaps do you see currently in Sutskever's list? Are there like important ideas? Are there communities or research directions that you feel just aren't represented in this list?
Yeah, for sure. As previously mentioned, I think reinforcement learning is one, maybe causal models. It has one paper on pipeline parallelism, but it doesn't seriously cover a lot of the plumbing and the architecture that goes on in the background of actually implementing these systems at scale. It doesn't cover hardware, really. I mean, there are a couple of mentions maybe in AlexNet and DeepSeek 2. It's not seriously trying to explain a lot of areas. I think that's kind of like a bug for sure, but also a feature. It's not trying to do everything. It's not trying to be a history of AI. It's not trying to kind of like give equal sort of attention or consideration to all of the different paradigms in machine learning. I think there are a lot of really good books that do those things. This one is a little more deep learning centric. It's trying to be Pareto in spirit, I guess. It's trying to, say, really cut out all the noise. Here are the handful of things you need to understand to appreciate a large piece of the field today. And, 90% might be an overstatement, but I think it achieves that to some reasonable expectation.
Are there overlooked traditions that you think deserve more weight? So maybe it's neuroscience or maybe it's system engineering.
Yeah, I'm sure. But again, like anytime you entertain that kind of question, you suddenly say, well, it's not a list of 27 things. It's a list of, well, we've got to, we've got to bump up those numbers, and now it's 40 papers or more. It becomes something else. And the book's already at 100 pages. If you added any more papers, you couldn't do a deep dive into the papers, and then it would just be kind of this superficial thing. And so, I think the book is definitely going to have holes and shortcomings, but I think 27 is a good number because it allows you to provide context, and it and kind of like do a little bit of world building for each of the papers, but also simultaneously enough real estate where you could dive deep on the technical details of the paper. And striking that balance is a tenuous thing. Once you start saying, okay, well, neuroscience has to come in, it's like, well, then something else has to come out.
Having studied the list deeply as you have, do you think that the Ilya of today would change anything? And if so, what might be added to that list from even just a few years ago? Obviously, the field has moved incredibly fast.
Yeah. Probably like the reasoning and test time compute stuff, which I add to kind of like round out the book just so readers understand. Like, so he has several papers about reasoning models. And so this is like differentiable kind of reasoning. It's deep learning models that have some sort of bias toward reasoning. So maybe it's graph-based deep learning, or it's relational network, whatever it is. That's basically the end of the list. It's about 21, 22. And so it's all pre-ChatGPT even. I think ChatGPT came out, what was it, November of 2022?
Yeah, I think so. Yeah.
Yeah. And so, that's before we got reasoning models, and we got test time compute and DeepSeek and a bunch of other innovations, agentic systems, even multimodality, more or less. I mean, there were obviously some visual transformers included, but the list doesn't really include that. And I think if he were to change anything, I suspect that that's something where we would see the list grow.
There seems to be a growing interest in alternatives to transformers, like state space models. Do you see these as extensions of the ideas in this list, or do you see them as a potential paradigm shift?
Probably an extension rather than a paradigm shift. There's certainly overlap with some aspects of CNNs and RNNs and even transformers. I guess transformers probably constitute a paradigm shift. It purged like these very comfortable ideas that we needed recurrence to model language, for example. And so in that regard, I think it's sort of a paradigm shift. There's transformational. In another sense, like it is sort of like an engineering field when you read the book, read through the papers, you realize that they're all just really kind of like, I think we look at it retrospectively as a paradigm shift, Transformers, but at the time, like there was already attention, and I think people already understood where the limitations of RNNs and CNNs for modeling language was. And so they're really just a series of incremental steps that engineers are just like constantly tweaking and moving the frontier, and we interpret them as like phase transitions after the fact. And so I think maybe both, I guess, at least as it relates to Transformers, I think it's both an extension and a paradigm shift. I think SSMs, we'll see. I think there'll probably be an extension, maybe no paradigm shift, but again, we'll see.
Let's talk about the future a little bit. I think all of this brings us to the questions that are kind of sitting just underneath everything. What do you think comes after large language models, or what is evolving beyond them?
I don't know. That's so hard to say. I
Yeah.
would probably go back to my previous answer and just say like everything is refinement, everything is engineering, which is just refinement. Like we're slowly learning how to use these tools more efficiently and more natively. What I've learned, even just firsthand, is like my own experience using the technology, building with the technology, is that it's painfully slow to like really understand the technology and how to use it natively for problem solving. I think that's just a general condition of like the human understanding is it just takes us a long time to understand new technology and how to build with technology. I always think about the Iron Bridge, which was built in, I think, the 18th century, 1700s, and they used woodworking techniques to build with iron, and they did it for nearly 100 years. Like riveting wasn't even a thing for another 100 years after iron was introduced. And I think in the same way, like it's obviously moving a lot faster, but like we had language models and we realized, hey, they weren't great at sort of like these non-monotonic reasoning tasks. And so we need to allocate more compute at test time and at inference and like agents and NCPs. And like there are all these new tools like riveting that we're figuring out are needed to complement the technology and to really build and scale with the technology. And so everything is just refinement, and that just takes time. As it relates to LLMs, they're used by hundreds of millions of people. And so I don't think they're going anywhere.
Are we refining the current paradigm, or do you think we're heading towards something fundamentally new?
I think ultimately what we will need, and I talk about this in the book, which is like there's a lot of excitement around the technology. There's also a lot of skepticism around the technology. Instead of like these literary skeptics or what I call people that have like kind of paper doubts, we need people with dirty hands. We need people with skin in the game who are building with these tools, building new benchmarks, new evaluation metrics. I love the work that Francois Chalot is doing with ArcAGI. Those are the kind of things that are going to move the frontier forward. Like we need to figure out more robust public criteria that is ultimately resistant to contamination and is actually measuring the thing that means the most to us. And we need people building stuff. And that's the thing that moves the frontier. It's not like sternly worded Substack post or, LinkedIn post.
What research directions or breakthroughs should we be watching over the next, let's say, 1 to 2 years?
Yeah, benchmarks. I think benchmarks are what's going to drive the field forward. So I don't know how to answer your question directly, but I think, if you build better benchmarks, it will drive the field forward. And I point to ArcAGI again in that regard.
We're not just talking about academic conversations here, it affects professionals everywhere. So, which areas feel underhyped but important?
Yeah, can I say benchmarks and evaluations, evals again?
Sure, sure.
Yeah. I mean, it is the tool that engineers need to understand their work. And it's the thing that we measure progress again. Going back to a statement I made earlier about sort of these really tenuous notions of intelligence, and it dominates the conversation when we start talking about artificial intelligence. But the thing that actually matters are evals.
And again, just talking about professionals everywhere, what do you think the best role for domain experts is? Maybe we're talking about medicine, maybe it's law, maybe it's public health, etc. But what do you think the best role for domain experts is in this AI saturated world?
Yeah, that's a good question. I mean, engagement. I think we need more people with living hope and living doubt. Again, contrasting that with C.S. Pierce's idea of paper doubt and paper hope. It's not enough to just talk about it or hit up social media and complain about the technology or to sort of evangelize the technology. I think you need to use the technology. Ethan Mollick has a great idea, the jagged technological frontier. And so it's like, invite AI to the table. And I think that's really salient advice. That being said, like, I don't think ultimately it's enough to just like prompt the models, although you have to do that. Again, maybe like engaging more deeply with the technology with respect to safety or governance or evals. Going into this, I did not think I was going to be advocating for evals so much. Um,
For these professionals, should they deeply engage now? Should they partner with AI labs? Or do you think that they should wait for the field to mature?
I don't know if there's any point to waiting. The technology is being used by hundreds of millions of people. I think the more hands-on you are with the technology, the better off you're going to be in understanding it. What I've seen and maybe a catalyst behind the book is that a lot of engineers are very confident. However, they don't engage with the research really well or frequently. I would encourage them to also read my book, which is entirely self-serving, but it does ground a lot of the things that are happening in the field in a more substantive way.
Relating to these last few questions, what second mountain should professionals prepare to climb, if there is a second mountain?
I think domain experts are in a unique position where like simultaneously, like intuitively, when you think about the technology, you think about the democratization of domain expertise, right? But what I've seen is that, domain experts know how to prompt the models. They're in the strongest ability or the strongest position to kind of interpret the output. So I think they're going to get sort of a disproportionate ROI on using the technology because they already have all the foundational knowledge. They're going to be the drivers, honestly, of maybe the most compelling products when it comes to AI, just because they're going to understand user problems. They're going to have already like walked a mile in the shoes of the people who could benefit from the technology the most. If I would try to connect the two, like this is a book that is definitely for engineers. Your question about domain experts is like, for engineers, understanding the domain that you operate in and trying to walk a mile in someone else's shoes, I think that's going to be a discriminator, sort of a differentiable kind of advantage for you.
And now I'd love to just kind of maybe bring it back to the reader. We have a few questions in this regard. If someone studies Sutskever's list carefully, how do you think it'll change the way they think about AI?
Hopefully one with just more clarity about what has actually happened over the last 15 years. I think the book makes some attempt to try to resolve the competing narratives between kind of like at one end, there's a little bit of hype, and at the other end, I think a little bit of skepticism in trying to sort of understand how perhaps both of those positions are often framed in fallacious ways. I think the compression lens is a really useful mental model. Representation learning, I think, is a really useful kind of mental model. The book isn't just a technical analysis of academic white papers. It is really trying to provide weight and a little bit of world building for like the world that they entered and why they exist. Also, how they persist, like how are they still impacting AI today? But it's also trying to like for each paper, like when these things were introduced, there was a like excitement and a little bit of skepticism. So the book also tries to like maybe it's frame them in a try to analyze, I guess, the different narratives and show how they're often fallacious, and then sort of reposition the reader toward maybe a more defensible interpretation of what has actually happened in the fields. Again, sort of like hinging a lot of that on prediction and compression and representation learning.
On a personal level, after immersing yourself in these papers, what idea or perspective changed your own understanding of intelligence the most, would you say?
And I think all of us kind of have this, but I have had this kind of like knee-jerk reaction to the field using terms that are anthropomorphic, things like learning and intelligence and thinking and reasoning. I think a lot of people kind of latch on to this as like, oh, that's not real intelligence or that's not really reasoning. There's a piece of me where that argument resonates because I want to be exact, and it's like, well, what is reasoning even mean, especially for a machine? And so you want to move away from the metaphors and the intuition. But I think what I learned, or appreciated at least more after completing the book, is that those are really important. Like, it's really important to have intuition and to use metaphors. And it is what like kind of like motivates us to move, to do something. And it's really, it's hard to talk about the technology in like these very technical terms anyway. And like nobody would understand what the hell we're talking about if we did. What I've understand is like it's okay to talk about artificial intelligence as intelligence. And in chapter 9, I lay out my argument more holistically, but I ground it in Ludwig Wittgenstein's work and Alan Turing's work. I have a new appreciation for what he was trying to accomplish with the Turing test and how he was trying to get everybody to move away from these philosophical discussions about what is intelligence. And let's just talk about intelligence in this case in purpose, which is against a benchmark. If we come to some sort of consensus that, hey, if you beat a benchmark of human reasoning, we could say it's reasoning. If you beat a human benchmark, that's human performance against a narrow task, and we call that intelligence, we could call it intelligence in an artificial intelligence as well. We don't need to adjudicate our whole vocabulary because, to Wittgenstein's point, it's like we're just playing language games and there's no essence over these words anyway, even if we try to put it there. And so I think that's what probably frustrates me the most when you go online. And I'm sure maybe you have a similar experience where it's like you can't have a discussion with anybody nowadays without being like, well, it's not actually intelligence. And they're like trying to withhold an accomplishment by machine learning against a benchmark that's difficult to interpret anyway. Their argument is hinging on this essence or this invisible thing of like humanness. Okay, we just need to kind of move on from that. And I think when we do, we'll just be in a better place.
I know that we've covered a lot of ground, everything from intellectual history to the future of AI here. And I'd love to hear what's on maybe some of the minds of the folks who have joined us. Does anyone have any additional questions that they want to drop into chat and ask Rich before we end?
Yeah, there are a few questions that were added. But before I ask them, I just want to piggyback on what Rich said. If you do not follow him on socials, you should. He's fantastic and entertaining and great. So his X/Twitter is /Heimann, and then he's also on LinkedIn. He's a great follow. So you should do that. And first we have a question from Todd. I know you covered this a little bit, but specifically he's asking if this list is becoming canon for understanding a certain discipline or a certain period of the discipline, what papers or at least topics would need to be added to the list to fill in the gap between when the list was created and now. So I know you covered the topics, but do you have any specific materials that you could suggest?
I don't, not offhand. I could give it some thought, and maybe that's a good social media post that I could add to LinkedIn and to X on like the last paper I think is 2021 or 2022. It's like what has happened since then that could be a really good appendix to the book.
I'm just going to skip to Todd's second question. He said, if it's not clear where AI is going in general, from an engineering perspective, what seem to be the 1 to 3 major hurdles to overcome right now?
It's probably still context windows. I think somebody asked a question about SSMs. One of the really virtuous kind of artifacts of SSM is context window. I mean, it's still quadratic scaling in inside of a context window because it's doing in this pairwise kind of thing with words to every other words. And so, if you have 500 tokens, that is, that's so much compute. If you double that, you're going to have a 4-time increase in compute. And so that kind of quadratic scaling, I think, is a thorn in probably every frontier company's side.
And then we have Allie's question, which is, are there any other books out there that you'd recommend to read before your book in preparation?
I would love to get your feedback if you did purchase the book of like how you feel, but I tried to kind of like introduce this to somebody who doesn't have a great deal of foundational knowledge in the field. Like chapter 1, for example, is just about AlexNet. And the reason why the chapter is so long is, one, AlexNet is an inflection point in the field, but also because I try to like introduce a lot of the concepts early. You don't necessarily have to have a lot of experience. But that being said, there are a lot of really good Manning books about deep learning. And some of those I'm sure are introductory level. And that would probably be a great precursor since the list is all about deep learning. Francois Chalat's book about deep learning is a great book. And if you're looking for like one book, that would probably be my recommendation.
Todd asked another question that's kind of similar to Allie's. What other resources helped you most understand the references on Ilya's list?
I mean, the papers themselves and just reading the papers that those papers cited, that was my approach to the book. Many of the papers I had already read. So some of this is just experience. I've been in machine learning for 15, 20 years, statistics before that. So I had a little bit of work. There are also some examples of books that were really popular 5 or 10 years ago that have not aged as well. It kind of like built up an intuition that I think everybody in the field tacitly accepted between sort of bias and variance trade-off that turns out not to be exactly true, even though we kind of like all accepted it to be true. And the work on double descent underscores how or where it was shown to be insufficient for understanding the statistical mechanics of deep learning specifically and training them past the interpolation thresholds. And so maybe what I'll do is I'll create a list that has some of the books that I think have aged exceptionally well and a couple that were probably canon 15 years ago that because of this period over the last 15 years have not aged well. And I think maybe because they don't explain the bias variance trade-off well for deep learning, or maybe they didn't sort of anticipate the optimization challenges for machine learning.
To piggyback off what you said about Francois' book, his books are some of our most popular books. I know that we're kind of patting ourselves on the back there, but like it's backed up by people's reviews and such. Every time we post about them, people are like, oh, this is one of my favorite books. This book is fantastic, etc. So definitely get in there on those ones for deep learning for sure. And that covers it with our Q&A. So I really appreciate all your guys' questions.
Rich, thank you. We appreciate all of your thoughtful responses and answering all of the readers' questions today.
Thank you for your time and the questions. They were great. I really appreciate everybody taking time out of their busy schedule to hang out with me.
Get this book at Manning.com.